Why I value is 2 for NaCl, why I value is 1 for glucose, and why I value is less than 1 for benzoic acid. Hi students, if this topic of Van't Hoff factor confuses you, watch this video till the end. You will never feel difficulty and you will remember everything and solve the questions fatafat from this topic. My name is Komali, I am your chemistry mentor. Thank you so much for clicking on this video. Coming to this Van't Hoff, what is this Van't Hoff factor? Let us see. For example, I have suppose glucose. What I am having? I am having glucose, and this glucose I am taking 1 mole. This 1 mole of glucose I keep in a solvent. What we expect, 1 mole should be 1 mole. So actual glucose is it is 1 mole. I am expecting is 1 mole. Okay, 1 mole and expected is 1 mole, and expected is how much? I am expecting it should be 1 mole. After dissolving I am getting 1 mole only. That is completely fine. Let's say if I take NaCl, how many moles I am taking? For example, 1 mole of NaCl I am taking. So I will expect that it should be, expected particle should be, I am thinking it should be 1 mole. But expected particles should be 1 mole. But what's happening, students, you know, it is this NaCl, it is breaking down into Na plus and Cl minus. So 1 mole of NaCl is giving how much, you know, 2 moles of particles it is giving. So here expected particle is 1, but actual particle how many it is giving? Actual particles it is giving 2 moles of particles it is giving. Then what is the problem? Okay, glucose you are taking 1 mole, so you are expecting it should be 1 mole, it is actual also 1 mole. But NaCl you are taking 1 mole, you are expecting NaCl should be NaCl only, but after dissolving it is breaking in giving 2 moles of particles. Then what will happen? Both I am taking glucose also 1 mole, NaCl also 1 mole. But 1 mole of glucose is giving 1 mole of these particles, but 1 mole of NaCl is giving 2 moles of particles. Then one property, colligative property, is the property which depends upon the amount of particles. So you are taking both, you know, 1 mole only, but particles are changing. If particles changes, colligative properties also changes. Then to avoid this problem, Van't Hoff is the name of the scientist. He introduced I, that is called as Van't Hoff factor I. Then he gave a formula. Van't Hoff factor I is equal to actual particles by expected particles. For example, for NaCl, it is breaking down into Na plus Cl minus. So actually, what we expect, NaCl should be 1 mole. This is what we are taking, that is expected one. But in reality, in experimental, how it is breaking into 2 particles. So it is breaking into 2. This is a I value. Got it? Van't Hoff, he gave a formula that which is equal to, I is equal to observed colligative property. This is the experimental colligative property divided by theoretical colligative property is the formula he gave. And colligative properties are, this one is, you know, we can say that inversely proportional to the molar mass. Why? For example, I value, for example, NaCl, sodium is 23, its molar mass, chlorine is 35.5, total it will be 58.5 is the molar mass. But after breaking like this, what is this? Na plus 23, 35.5. Its molar mass is decreasing. Each particle molar mass decreasing. So I can say that as number of particles increasing, colligative properties increases, but each ion molar mass decreasing. That's why I will write inversely related. From this formula I can write the above one as both are inversely, right? So here denominator, in this case it comes to numerator. So same formula I'll write it as theoretical molar mass divided by, tell me students, what we'll get? Observed molar mass. Observed molar mass. Theoretical molar mass divided by observed molar mass. Is it clear? Now, okay. How to find a simple, easy, very easy. If you just follow this video till the end, after that, fatafat you will do the questions. Van't Hoff factor is there, no? Van't Hoff factor I. Two things may happen. Substance, it may undergo dissociation or it may undergo association. If dissociation means breaking, like NaCl is breaking into Na plus and Cl minus. In such case, directly use this formula. Ma'am, how, if you want to know how to get this formula, for full derivation, comment me in comment section. Next video I'll make it. I is equal to 1 plus n minus 1 into alpha. Repeat the formula, students. What is the formula for dissociation you have to use? I is equal to 1 plus n minus 1 into alpha. If suppose the substance is undergoing association, combining, we will see what is the meaning of that. I is equal to, use the formula 1 plus 1 by n minus 1 into beta. See, alpha is a dissociation, degree of dissociation. Beta also degree of dissociation. Just to show the variation, I am taking this. Repeat both the formulas. I is equal to 1 plus n minus 1 into alpha here. In this case, I is equal to 1 plus 1 by n minus 1 into beta. Is it clear? Right. Now, ma'am, what is this association? What is this dissociation? For example, one substance is breaking. The substance can be, it may undergo, for example, what type of substance it can be? It can be an electrolyte, strong electrolyte. It can be a strong electrolyte. It can be a weak electrolyte. Second type, weak electrolyte. Or if the substance is non-electrolyte, it don't undergo any association or dissociation. There is a special category, non-electrolyte. Non-electrolyte. Okay, students, is it clear? Non-electrolyte means it don't undergo any association or any dissociation. Let me give you example. Urea, glucose, fructose, sucrose, all these are non-electrolytes. Okay, in this case, alpha is 0. Very, very important. What is 0? Alpha is 0. Alpha 0 means it don't undergo any association or any dissociation. Then use the formula I is equal to 1 plus n minus 1 into alpha. Alpha place keep 0. Then what is the formula we will be getting? 0 into this entire term becomes 0. Then I is equal to just 1. Now tell me, for urea and glucose, what is the I value? I value 0. Coming to the strong electrolytes and weak electrolytes, how to calculate? For example, strong electrolytes like strong acids, strong bases are weak. In case what will strong electrolyte means, the substance will undergo 100% dissociation. 100% means 100 by 100. 100 by 100 means 1. So, I is equal to 1 plus n minus 1 into alpha. Now, what you do? 1 plus n minus 1 into alpha value is 1. Just multiply with 1. Then what you will get? 1 plus n minus 1. Minus 1 plus n will be cancelled. We get only n. This is the I value. Very simple. Correct? No? So, for strong electrolytes, what you have to take? Directly number of particles will give the I value. For example, strong electrolytes can be strong acids, strong bases. You can take salts also. For example, strong acid. HCl, how it will dissociate? H plus plus Cl minus. What is the number of particles you are getting here? 2. So, I value is directly equal to 2. Got it? Now tell me, in this H2SO breaks into 2H plus plus S4 minus. Number of particles are 3 total. So I value is 3. In this case HClO4 how it will break? Tell me. Like this. What is the number of particles? 2. So I value is 2. HNO3 how it will break? It will break into H plus plus NO3 minus. So what is the number of particles here? 2. So what is the I value? Tell me. I value is 2. Easy. Very very easy, right? Now see, a strong bases. How can you do this? NaOH dissociates into Na plus plus OH minus. So number of particles we get is 2. So I value is 2. BaOH twice, how it will dissociate? Ba2 plus plus 2OH minus. What is the I value, students, in this case? Number of particles are 3. So I value is 3. Very easy. What you have done? You considered strong electrolytes means alpha 100%. 100 by 100 is 1. If alpha is 1, you kept in the dissociation formula. You found it. If, for example, second case is what under dissociation? Weak electrolytes. Weak electrolytes means substances do not dissociate 100%. In such case, they will give us dissociation is 50%. They will mention. If dissociation is 50%, then what you will do? Alpha is 50%. 50% means 50 by 100. Zeros, 51s are 52s are 0.5. Substitute the same 0.5 in the dissociation formula. N minus 1 into alpha. Substitute this in this formula. Number of ions from that question, you take it and do the question. Easy, right? Easy, easy. For example, we have, this is actually under strong electrolytes. I need to discuss this. Strong electrolytes, 3 types. Strong acids, strong bases and salts. In case of salts also, Na plus Cl minus. I value is 2 directly. K2SO4 breaks into 2K plus plus SO4 2 minus. This one it will break into 2Al3 plus plus 3SO4 2 minus. Now can you tell me what is the, it is a coordination complex. For coordination complex, inside the coordination compound what is there? That is 1 ion. This entire thing is 1 ion. Don't worry if you don't know how to draw this. Just you take it 1 ion, and outside how many potassiums are there? Those many ions. So 4 plus 1, 5 ions. So I is equal to 5. In this case I is equal to 5. In this case I is equal to 3. Clear? Strong acids, strong bases and salts. Weak electrolytes you have learnt. Weak electrolytes, how to identify in exam? Weak acids or weak bases. Weak acid, HCN is a weak acid, acetic acid is a weak acid, H2S is a weak acid. Weak bases, ammonium, these are most important examples. Ammonium hydroxide and ammonia. Following. In this case, you should not take directly I is equal to N. What you have to do? I is equal to 1 plus N minus 1 into alpha. Alpha they'll give in the question like 45% or anything. Just substitute. N is number of ions you substitute and you will get the I value. Is it clear? Students, see. For association, we discuss the formula. What is the exact meaning of this association is, let's say A molecules are there. Okay. A combining and forming A2. This is called association. Let's say for example, 10 A molecules are there. 10 A atoms. Let's say A1, 2, 3, 4, 5, 6, 7, 8, 9, 10. These are combining and forming 5 A2s. Okay, so here number of particles are more, but after combining number of particles became 5. So number of particles decreases, so colligative properties also decreases. So colligative properties are the properties which depends upon the number of particles. So as the colligative properties are decreasing, to change this effect, Van't Hoff factor I is introduced. In case of association, what is the formula you have to use? I is equal to 1 plus 1 by N minus 1 into beta. Now, what I am going to do is, I am going to give you 3 questions. Okay, this is a question number 1. This is a question number 2. This is a question number 3. Try these 3 questions and let me know your answer in the comment section. In next video, I will post the 3 answers for you. This is the excellent trick box. Just simply for strong electrolytes, I is greater than 1. Weak electrolytes also, I is greater than 1. If it is a non-electrolytes like glucose, fructose, I is equal to 1. For if any substance undergoing association, I is less than 1. Try the 3 given questions. In next video, I'll upload it. My name is Komali. Thank you so much for watching this video. See you in the next video. Have a great day.